All right, let's have a look at a couple of examples here. Keep in mind now, this assignment basically is about calculating confidence intervals. We're doing two types of confidence intervals. Intervals on population means when samples are large, and we're also doing confidence intervals on population proportions. So there's that aspect of it. And then the other thing that this assignment covers is tests of hypothesis. And we're going to look at tests of hypothesis about a population proportion and again about a population mean, but when the sample size is large or when we know standard deviation. But anyway, we'll come to that. Okay, let's look at this first example. We're told here Allen's hummingbirds have long been studied by some zoologist. A small number of these hummingbirds, 15 of them in fact, have been under study in Arizona. The average weight of these birds, and when we say these birds and it says X bar, that's the average weight of the 15 birds. So that's my sample average, it's 3.15 grams. Based on a previous study, we can assume the weights of Allen's hummingbirds are normally distributed, so we're told that up front. And another critical piece of information here is we are told the true population standard deviation. My sigma value is 0.33 of a gram. Okay, the question is find a 90% confidence interval. So I want an interval. The level of confidence is going to be 90%, and the interval is going to be on average weights of Allen's hummingbirds in this study region. So I want a confidence interval on a population mean. We're asked to do it by hand, and we're also going to get Minitab to get the answer for us. Then we're going to explain what this interval means, we're going to interpret it, and then we're asked a couple of other questions. Okay, so first of all, we're dealing with a confidence interval. And hang on a minute now, I got to get myself set up. We need the formula for calculating a confidence interval. And I've already got that done here. And let's have a look at what I'm doing with this. So my interval, first of all, I've stated right here, it's a 90% confidence interval on mu. Mu is a population mean. The formula from your note says, take a sample, calculate the sample mean. That's the X bar value. We're going to go out plus the margin of error on one side and minus the margin of error on the other side. Now, how is this crazy thing called margin of error calculated? Well, it's based on a z-score, z of alpha over 2. The value of z that you use is determined by the level of confidence you need to have, and we need to have 90%. All right, times the standard deviation of the sample mean. And standard deviation of sample mean, central limit theorem has told us, is equal to the standard deviation of our population, and we know that up here, divided by square root of sample size. Okay, so I plug things in that I know. So this is equal to, I know the average weight of those 15 birds was 3.15, so that's here, plus or minus. Now, if you look through your notes on, I can't remember what slide it is, there is a slide in there that summarizes what z of alpha over 2 values we use for specific levels of confidence. And if we want to be 90% confident, that value is always 1.645. So there's that. Multiplied by the standard deviation of the population I'm picking the birds from, divided by square root of 15. Now notice here that my sample size is not large. Large in your note says 60 or more. It doesn't have to be large if we already know the population standard deviation, which is the case right here. All right, we work this out. 3.15 times 1.645 times this thing here, which is called the standard deviation of my mean. That works out to be 0.0852. Do the multiplication, and here's my answer. Okay, so there's my answer, you working this out by hand. Now let's go to Minitab and see how this would work. So these things are located under the Stat tab, Basic Statistics. We have just used something called a one-sample Z. We can do a test of hypothesis, which we'll look at here now shortly, or we can do a confidence interval, or we can do both at the one time. Later on in chapter 19, we're going to talk about the one sample T, but we'll save that for another day. Okay, one sample Z. If I had raw data, I'd put my cursor here in the box and whatever available data I had would show up over here. In this example, we don't have raw data. We have summarized data. What do we know? We know this researcher picked 15 of these birds. We know that the mean of those 15 birds was 3.15, and it's asking us for the known standard deviation. So really, we're supposed to be plugging in the known population standard deviation, which we were told was 0.33. Now, this business about perform hypothesis test, I'm ignoring that for the time being. I'm going to come back in here. Now, my confidence level, the default is always 95, so in this case we have to change that. We want a 90%, and we want the alternative hypothesis here to read not equal to, because if I say not equal to, it will give me an interval where there will be a lower end point and an upper end point. I say okay and okay, and here's the information that I get from Minitab. And I'm going to copy that information, and hang on because I'll come back to it here. Back over here, I've just copied that into my document. And when I look at the information that I'm getting out of Minitab, first of all, well, I've done the one sample Z. This is referred to sometimes as a Z interval because we're using the standard normal distribution. The assumed standard deviation is my population standard deviation. We are giving it some sample data, sample size, sample mean. It calculates the standard error of the mean, by the way, and notice that 0.0852 is the same value, that I get right here by hand. Okay, there's my interval. I rounded my interval off here to 2 places after the decimal. Minitab's given me 4. Well, up to you, but I think 2 is sufficient. Okay, so Minitab and whatever we've done by hand agree. Then we were asked in this question, we're asked to interpret the interval. So, okay. What the heck does this interval mean? Well, I've already typed it in, so here it is. I can say we are 90% confident that the true mean weight, or you could say true average weight, of all hummingbirds in Arizona, actually probably what I should say, no, I shouldn't say in Arizona, hummingbirds in this study area in Arizona falls between 3.01 to 3.29 grams. So that gives whoever's reading my statistical report some idea of where the true average lies. Okay, so there's that piece of it. Now, what is the margin of error? The margin of error is the number that occurs after you've done the this whole thing right here. It's basically the plus or minus. So right here I can see my margin of error is equal to 0.14. 0.14 is half the length of my interval, and in fact, hang on here now, in fact I could take, where did that just go? Hang on, I'm trying to copy and paste something. Oh no, here it is. Okay, it took it but didn't put it where I wanted it to be. Okay, here's the margin of error. The margin of error is equal to the length of your interval. Take your big number, top end point of your interval, minus the lower end point, divide by 2. What are you going to get? You're going to get 0.14. That's half the length of your interval. Okay, next part of the question, find the sample size necessary, let's say necessary for a 95% confidence interval with a maximum margin of error of 0.08 for the mean weight of these birds. Okay, what is it we're looking for? We want to know sample size. We want to know N. And we want N so that we can estimate the true average weight of these Allen's hummingbirds. Not only do we want to estimate it, we want to be 95% confident in our estimate, and the margin of error, in other words, half the length of the interval, can only be at a maximum 0.08. Now, to answer this question, there is a formula in your notes, and I'm going to copy and paste it. I've got it here. Well, I thought I had it here. It keeps popping up front. Hang on now. Let's get going here. All right, here's the formula. N is equal to, and this is the formula we use when we're trying to calculate sample size for estimating population means. So it says you have to find a z-score. The z-score you use is the z that corresponds to, in this case, 95% level of confidence, because that's what we were asked for in the problem. Up here it says we want to be 95% confident. 95% level of confidence always corresponds to a z of alpha over 2 value of 1.96. All right, I'm supposed to know my population standard deviation, or I can estimate it with a sample standard deviation, but in this case I know the true sigma value to be 0.33. My margin of error, I'm told in the problem, is 0.08. You multiply and divide, and don't forget you got to square it at the end. Your calculator answer is roughly 65.36. You always round up to a whole number, and always round up, 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 never down. So in this case, if we wanted to do a study to estimate the true average weight of these birds, we want it to be 95% confident, and we wanted the margin of error to be only 0.08. That's going to require 66 birds, randomly picked. Now, just to illustrate here, our margin of error up here is 0.14, which is bigger than this 0.08. And when I got this interval, this was based on only 15 birds. 15 birds is going to result in a larger margin of error. 66 birds will result in a smaller margin of error. And ultimately, at the end of the day, you're trying to estimate a number of a population, and the tighter that interval is, the more information it's giving you. Before I finish this question, just a note. Your textbook uses Y bar every time it talks about a sample mean. I am very much used to using X bar as the sample mean, so don't get too confused here. I know I've got X bar here, and down here I've got Y bar. Well, you know, it doesn't matter what letter you use. The fact is, it's a letter with a bar over it. It represents a sample mean. So just a little note on that. All right, the other parts of this, these work solutions, I'm going to do in separate videos. Otherwise this thing is going to be horrifically long. Okay.